Hello and welcome back. This time we've got another problem here. Let's read it. The number of adults, children, and seniors attending the zoo over Friday, Saturday, and Sunday is shown in the table. Entry prices for adults, children, and seniors are $35, $25, and $20 respectively. Using technology or otherwise, perform a matrix multiplication that will determine the entry fee collected for each of the 3 days. Alrighty, well, we've got a table here. We can just turn that into a matrix quite easily. 125, 245, 89, 350, 456, 128, 421, 523, 102. And then we've got another piece of information, which is that we've got the cost, or the prices, just here, 35, 25, and 20. And you might think, okay, well, I'll write it like that. I'll try that. 35, 25, 20. What we can do is we can check whether this matrix multiplication will even work. So our first matrix, if we think about the order or its dimensions, this is a 3 by 3 matrix. And we're multiplying by this. Now how many rows does that have? That's got 1 row and it's got 3 columns. If we have a look at the internal dimensions, or the dimensions that are next to each other, the 3 and the 1, they're not the same. These are not the same. So this does not work. It's not possible. You can't do that multiplication. So let's go back. And let's look at it slightly differently. So we've got the information, 35, 25, and 20, but it won't work if it's a horizontal matrix. Let's try a vertical matrix and see if that works. 35, 25, and 20. Alright, let's just check the order or the dimension really quickly. So this is a 3 by 3 matrix, and we're multiplying it by a 3 by 1 matrix. Okay, good. Now let's have a look at the internal dimensions, the last one and the first one, and they're the same. Fantastic. Now our that means, by the way, that they can be multiplied together. Now, if we look at the outside dimensions, the 3 and this 1, that tells you that your answer matrix will also be a 3 by 1. Now, if you use your graphics calculator or some other method, we know that it's row multiplied by column. So we have 1 row here, and we have 1 column here. And you can only really do that 3 times, so we'll have 3 different answers. And if you pop that in your calculator or work it out, we will get $12,280 collected on the Friday, $26,210 collected on the Saturday, $29,850 collected over the Sunday. That's it. Now B. A, let me just check. What's that say? Perform a matrix multiplication that will determine the entry fee collected for each of the 3 days. So I've got my Friday here, my Saturday here, and my Sunday here. Oh, that's Sunday. Everyone can read that. Fantastic. A, yeah, I've done that. Good. Now for B, write the calculation that finds the entry fee collected for Saturday. Alrighty. This one doesn't say a matrix calculation, it just says the calculation. So Saturday, we've got 350 adults. That would be $35 per ticket. Plus, how many children do we have? We got 456, and they have to pay $25. And seniors are cheaper than children. This is a great place. And 128 times 20. And if we multiply and add all these up, this is for the Saturday, you'll get $26,210. So this was our working out for A. This is B here. And now C. Let's read C. Is it possible to perform a matrix multiplication that would find the total for each type of entry fee, adults, children, and seniors, over the 3 days? Explain your answer. Well, look, the answer is either yes or no. That's it. But which one is it and why? Um, well, we just did a matrix multiplication up here. We got the total for the Friday, the Saturday, and the Sunday, but not the total for the adults on the Friday, not for the total for the children on Friday, etc. If we were going to do that, let's think about the order of our matrices. So we've got a 3 by 3 matrix to begin with, and we want to multiply that by some kind of matrix, not a 3 by 1 or a 1 by 3. And our answer, we want that to be a 3 by 3 as well. Okay. This doesn't seem too bad. Now, for this multiplication to work, this has to be a 3. These two have to be the same number, otherwise you can't actually multiply them together. And if we have a look over here, we can see this 3 is this dimension here, just like this 3 was this first dimension. That would be the rows for each matrix. And then we have the number of columns, 1, and that comes from just here, this dimension here, or the order of it. So the number of columns in this matrix have to be, it's got to be 3, otherwise this answer matrix wouldn't make sense. Let's see what we can do with this information. Okay, so the first one is the number of people, the type of people, and the days they came. So that's our regular matrix that's from the table. 125, 245, 89, 350, 456, 128, 421, 523, 102. And we need to multiply it by some 3 by 3 matrix to get the total cost or the total price of all the adults on Friday, children on Friday, seniors on Friday, etc. Okay, so first of all, let's just think about this adult on Friday. We know that it's $35, right? Great. And we know matrix multiplication, it's row by column. And if we want just the adults here in this first element of our matrix, we don't care about children or seniors, so we'll just make those zeros. Okay, so row by column, when we do that, we'll get 125 times 35. Well, let's keep going. Let's see if we can develop this matrix a bit more. Next up, we've got children. So the children, I'll use orange for them. They'll be right here. The second element along to the right. 245. So 125, we don't care about that. So that'll be 0 because we do row by column. So 125 times 0, that's 0. 245 times 25, because that'll make the number of children multiplied by their ticket price or entry price. And seniors, we don't care about them. We're not going to add them on to this section. So this orange section will just be 245 times 25. And let's use a different color again. Oh, how about a nice green? Very nice. We want seniors now. So the number of adults times 0, because we don't want to add on their price. The number of children times 0, don't want to add on their price. And 89, finally, times 20. Alrighty. Now this, you might recognize as a diagonal matrix where the leading diagonal has values in it and the rest of the values are 0. What this does is allows us to multiply specific columns by certain values. It's kind of like a combination of just multiplying all the adults, but it lets you do it in matrix multiplication. So if you ever want to get single totals, think about a diagonal matrix. We know a 3 by 1 or a 1 by 3 matrix wouldn't work, so we've kind of stretched out those matrices into this. Now, let's work that out. We've got 4,375. This is for the adults, children, and seniors. And this is for the Friday, the Saturday, and the Sunday values. This will be 6,125. I've cleaned up that dot that was hanging around. The seniors on Friday, 89 times 20, that's 1,780. The adults on Saturday, whoa, 12,250. Big spenders. The children, quite a large number again, 11,400. That's just 456 times 25. And the seniors on the Saturday, 2,560. Adults on Sunday, that would be 421 times 35, which is 14,735. The children, 13,075. The seniors, $2,040. So when we're doing the total for each type of entry fee, or the total of any kind of large matrix, we could do all the individual calculations, or we can combine them into a diagonal matrix. Keep that in mind if you've ever got to do something like that. All right, that's all the time we've got for today. Thanks for joining me, and I'll see you next time.